Alright, let's do this. Hi. So, first of all, do you like my wallpaper? I decided to keep it. Usually I change them pretty quickly, but this one brings some nostalgic memories for some reason. No idea why. So I'll keep it for another stream or two, who knows. Second thing is, yeah, I didn't stream yesterday. I couldn't motivate myself. I don't know what happened. I was busy at work. Yeah. I'm at an age in which work gets me tired instantly. So let me think about what I should do next. So these are the files we are having. We are modularizing our project in a way to reduce the line load on this guy. How many lines do we have? 731 lines of code. So yeah, initially I wanted to make this as lean as possible, which I realized being lean as possible, meaning leaving just the main, which I don't want to do it. Feels like striping the main method of the main file of too much logic. So let me do this then. I'm gonna just no, it's this guy. Let me make sure that this works as it should. Nice. Built everything properly. So what can I extract here? Lol print, lol join, lol take. I think both of these can go to lol ops file. Lol add, lol pop, lol delete, lol copy. Yeah, I think both of these will find their place in the sun right here. Let me go to the end again. Wait, what have I done? No, go to the end, paste them. Have pasted those guys. Lol take, lol join. Yeah. Lol add, lol join, lol take, like this. So what were these two methods doing? Join as long as we have elements in the y element, I'm adding to x whatever we pop from y. So this one counts the elements and this one is popping them one after another until there's none of them left, and then I just delete epsilon. All right, cool. And this, my friend, it just takes the element. All right. Lol print. I think the print operators should be in a file of their own. Built-in head. These are the helper methods. I might leave them here. Yeah, these are the built-ins. I should create something for them as well. Oh, it's a long file. Let me close this. Try building it. It won't work now. Yeah, it won't work. Why? Because in this function I have multiple definitions, so I need to add what I need to add. ops.c. I need to add I need to forward declare both of these. Yeah, I'm also bored of doing this. But to be honest, it's a simple, even meditating thing to do. I'm just exporting code into another file, and there's not a lot of room to break something. Yeah, it's a meditating experience. Add pop. No, wait. An error. Only moments after I said that cleaning the code is the easy part. First defined here 19. Where's 19? What? I will join. There is the same error. I will save this. Yeah, so I didn't save my strings.c file. All right. So how many lines do we have now? Seven hundred fifteen. Touch lol print.h lol print.c. Let me just use lol ops.h as a reference. Oops. So these will be the print helpers. I need types, constructors, a macro to make sure that we defined this file. If not defined, I will print.h define, and if void lol expression print lol v character open character close. This is the definition, save, close. Now here let me enter the visual. What? Copy. What? Was I having a bug the whole time here? Ops.c. Lol print.h. Again, let's copy my friend here. I think I already did this, but I can do this again. I can waste more time. What? Oh, not here. I want it here. Save. Move here. Select this guy again. Delete it. Oops. Okay, so it doesn't work. Undefined reference to lol expression print. What line? What line? Where are you? Where do you? 34. So it's here. Lol expression print. Lol expression print. It should be here, right? Cat lol print.h. Yeah, I have it here. I'm exporting it. Lol expression print. Why is this happening? Why is this happening here? Oops. Lol types, lol constructors, lol ops. So these are the only two places where this method is used. Ah, I know what's this. I know what it is. I know what's broken. So this should be also lval print.c. We need another file to compile here. Implicit declaration of function lval print. What do you mean? Oh, okay. Now I should export the lval print method as well. Let me just get some water. Okay. Let me just see what this method does. So lval expression print, we provide a Lisp value, we have a character that opens, a character that closes. We put this character to the terminal, and then as long as v has elements, I should print the cell at I. If e is not equal, the last element, right? The last element in the Lisp value, I put a string here, and then I put the closing one. All right. So next thing to do is to select this boy. Maybe even print new line. Nice. Okay. So what do I have here? I have expression print, and now I have print and print ln. I should also copy print string. Yeah, I should also copy this one most probably. What? Ah, it's like this. No, not like this, but like this. No. Why have I closed it? So what is the print string doing? So we allocate the size of v, then I copy whatever is in v string into the content, then I escape the content. I assume, what should this do? No idea. Then I print the content and I free the content. Okay. Let me just add this method here as well. Print string. Can remove the definition of print here. How many lines of code do we have now? 600. Ooh, 667. So the devil number returns 0. All right. Alrighty, let me go here, close it, build it. Yeah, it works, it works, it works. Maybe I could test this. Def like this. Param list. All right. So this should be 210. All right. I think it's working. It's working. It's okay. Do I have any more print methods here? Print. Elbow print. No, this is nice. So this is the only place still left in our main, in our string.c file where we print. So the last reference is here, which is I like this. I like the fact we are so mostly done with the print methods. Maybe Lisp environments should be. Maybe built-ins should also be a separate method. Built-in list. So the type of A, it's a Q expression, then I just return A. Why am I doing this? No idea. No clue. I could export all of these. I could export all of these. Built-in if, built-in lambda. Oh, I should do this. L-type name. L-type name. Who's referencing this? Built-in op. All right. Touch. Built-in.h. Built-in.c. I have both of these, right? I do have. Built-in.h. Built-in.h. Why do I get these automatic comments every time I go to a new line? No idea. Do I need? I'll see what I need. Let me try to define. No, I definitely need LL types. I don't know about constructors, but I definitely need LL types because this file wouldn't know what an LL is. So LL built-in list LL A LL built-in OP All right. So I can close you. I can open built-in.c and I can copy everything that starts from here and ends here. 47 lines, only 47. Built-in C. I'm just gonna include built-in.h. Oh, but I forgot. And now the last thing that I'm gonna do is oh wait, can I remove all these first? Can I select you and remove it? Save. And let's do all of this again. So where is this found? In function built-in OP. Built-in OP. Just a second. So it's here. I also need to define elval error. I think I do. I need to define elval error. How do I do this? How is this working, my friend? What's this? I definitely need to define that below. So let's try this first. Get elval is constructor. I think it's constructors. Yeah. So now down there in the same file, built-in.h, I'm gonna try to forward declare elval error character format and a list of arbitrary constructors. I'm not getting the error. Yeah, I'm not getting the error again. Where again? Built-in OP. So I need elval delete, elval pop. And string compare. Why is string compare not working? I need to include string.h, but why is it working in I'll always forget because I implement this mpc.h file, which most probably has string.h already included in it. All right. So I can also include mpc.h. I think I'm going to include mpc.h, but why would I include a whole file? Wait. Cut. Oh, these are constructor. What about ops? Same shit. Wait. What about lamp? Yeah, same. Okay. Not the thing I wanted to do, but I think I had to do. mpc.h save. So now I don't think I'm gonna have this error anymore. Oh. My bad. Include. I'll type name. I think I will put this method in the constructors file because, oops. Or maybe lvolops l-type name. So this is based on maybe lvol. Yes. I'm gonna put it in lvol types. Select all of these. Paste it here. No, I can paste this. This is a header. I should remove most of this. I will type so many files. Oops. Now the question is, will this work out of the box? So I shouldn't get the l-type name error anymore, but at the same time I should also build my lvol.types.c file. Wait. Undefined reference to l-type name. Lvol types. But I think I'm importing it here. Where are these happening? Oops. These are happening inside strings.c. built-in.h lvol types.h. Okay, so I didn't save a file. Oh, how many times this happened already? Three more methods to do. These are the lval deletes, lval pop, and lval pop. Function built-in op inside built-in.c. Lval pop. Wait, maybe I can just include, instead of defining them, maybe I can just include, oops, ops.h. Yeah, maybe I can just include lval ops.h, save, and try to rebuild it. Nice, 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 nice. So I don't even need. I have sausage fingers every time I miss the keyboard. I don't need this. Amazing. How many? 608. A lot of the file is yet to be trimmed. So let's do this. Let's give some more built-ins here. Built-in head, built-in tail. All right. Oh, it's already open down here. All right. All right. I added these two. I'm also gonna add them here. Oh, this is getting annoying. Ah, shit, also need insertions. Macros. So I need, where are you? Built-in.h. So now that's the only error I'm having. Built-in tail. Yeah, leave it to me to mistype. All right. For the first time since we started writing this, we are under 600 lines of code. Let me try to squeeze, to cut maybe 100 more. How much time is it already past? 42 minutes I'm streaming, and I didn't do any coding. I didn't do anything real, anything tangible. I mean, this is work as well, but okay, let's do this. Insert elbow built-in length. Let me check the environment. Let me check the Lisp value. Elbow built-in init, same description. Built-in cons. Why can't I just copy? No, I messed up. Let me yank this guy and paste it. Paste it here. I didn't yank. I didn't yank it good. Yank. Ah, double yank. Now it works. So this won't be built-in init. This will be built-in cons. Save. Select. Wait, let me first make sure this works. It works. So now, built-in length. What does it do? I'm asserting that the first element of the cell has a type of Q expression. If not, the argument is not a Q expression, got something else. Then I'm checking the length of this element, and I'm returning the LWL amount of length in it. So I'm certain that the first element is Q express. I haven't extracted this one, so this should be assert type. Yeah, let me just do this as well. No, wait. Yanking this, pasting here, removing this, removing this, removing this. Simple. Len, init, and cons. Same thing. Go to the bottom. No, no, my friend. Do it like this. So now I have built-in cons, right? Works. Where are we? 545. 545. Oh, there are a lot of built-in methods here. Look at all of these. Built-in def, built-in var, built-in def, built-in def. Ah shit, I need to define all of these now. So let me do the following. Let me select all of these. 93 lines. Yank it. And I'm gonna use ChatGPT. Okay, can you write me the how is this called? Methods, so I can put them inside my header file. All right, and I'm just gonna pass them here, save. Let's move here. So I'm removing everything from built-in join. No. Saving it. Saving this. Saving this. Leaving this. Oh. Oh. So it says here, in the function built-in def, we have an implicit declaration of a function built-in var. Do I have built-in var here somewhere? Built-in var, I do have. I have the built-in order here as well? No. Ah, it's here. All right. So I didn't copy built-in order yet. Will this work? I'm missing built-in order. Removing it from here. $421 lines. Oh fuck. In function built-in var. In function built-in var. All right, let's do this one as well. So length.h, I'm moving here, void def so this is length def. All right, so what I did now, I implemented the length, I moved the implementation of the, no, I don't want to type. No, I don't want to type, I want to use the visual mode, yeah. I moved the definition, I moved the method itself into the appropriate module. So now I shouldn't see length def anywhere. Wait, multiple definition of length def. multiple in functional length depth, multiple, what? The only thing that might length depth. Ah, I didn't save again. I didn't save again. Yeah. So what do I have here? I have 3 missing methods. Length put. I have elval eval and I have elval eval again. I think I have elval eval defined, right? Elval eval. Do I have elval eval? No. Elval eval. Ah, I haven't extracted it yet. All right, let's start with length put. It's here. I'm gonna do the same thing. Oops, select it. Open length.c, go to the end, paste it here, save this, close this. .h, imported void length put. All right. Now here I'm opening the visual. No. Give me back. This is it. Yeah, the only error we still have is the elval eval error. How many lines do I have now? Less than 400, nice. So elval. I'm gonna remove it from here and find the next instance. Here's the definition. Oh, this is the S expression. Where's the regular elval eval? It's here. But if I move this, I'm gonna also need the S expression. Ah! Let's do this. So this will most probably be envelopes, right? Yeah, I think it should go here. Save. keep getting more. As I remove more and more things, I keep getting more and more errors. So what do I need now? The S expression. Alright. Lval evil S expression. Oh. So this is the get method. Let's do this. Let's create it here. All right. I should also copy it, paste it, save this file as well, then remove it from here. Okay, I hope now that at least the first error will be gone. Why am I getting more and more errors, man? What the fuck? In function limit get, so here lval, so what's the name of this? Lval constructors. H save. Oh no, oh no, oh no, oh no, have I fucked something up? No! What have I done here? No. I think I might have, oh yeah. Error after error after error. Let me save this. Let me do this again. I had a cyclic import there, I believe. In function lamp get. First of all, it's not lamp get, it's lamp get. So maybe now in function lamp we get implicit declaration of function lval error. Lval error. So lamp get, this method should somehow see the LOL error method. The problem is I'm already importing len.h here, so if I import here LOL constructor.h, I will most probably get a cyclic dependency here. No. In functional lambda, yeah. So most probably yeah. So I made my first cyclic dependency here. I think I'm gonna end it after I fix this. And this build your own Lisp series. I'm gonna do something else, and you'll see. I think it's gonna be interesting, at least a little bit more interesting than this one. But first, let me take a glance at this. Maybe I can define it here. So it's LVOL error and LVOL call. I think these are the only two methods. All right. ls. So it's no, it's not the ops, it's the constructors. So it's no, it should be not error, it should be LOL error. All right, so the only thing I'm missing here? LOL call. I have it here. Okay, you know what? I'm gonna stop it. and I'm gonna continue. I think the last one will be the one that we finish will be the last one. And now I wanted to do something that is really interesting. And it's the fast inverse square root algorithm. Let me just get some water. Let me do a quick walk, and I'm gonna try to learn this myself. So be right back. And I'm back. Just a second. Okay, I hope you like my wallpaper. I won't change it for a couple of episodes, but the thing that I wanted to do is the following. Let me also copy this one and open it here. So, since I was a kid, I was reading about this really incredible snippet of code that was used in a video game that I played when I was younger. And I was really impressed because I took a glance at this method a couple of times, and depending on the point in which I looked at this method, my comprehension of this moved from I don't fucking understand nothing to okay, now it makes a bit more sense. So I wanted to try to understand this, to understand why is this important, why was it used, how did it improve the game, and you know how it works basically. So I also have my trusty tablet opened as well. I also have a new wallpaper on the tablet. Let me just show you. Bump. A cool, gloomy, dreamy forest. Okay. Here it says, an article and a research paper describe a fast, seemingly magical way to compute the inverse square root used in the game Quake. So let me just increase this a bit. So this is the inverse square root. I'm no graphics expert, but I appreciate why square roots are useful. Why? The Pythagorean theorem computes distance between points, and dividing by distance helps normalize vector. Now, here's where I start getting confused. Here's when it stops clicking for me. Let me just move this. Actually, I want to move it. I'll leave it here. So, why are square roots useful? One over squared x is it written like this? All right. Alrighty. Let me just. So why is this useful? The square root and its reciprocal are widely used in mathematics, physics, and computer science because they appear in numerous formulas and have important properties. Here is why the square root is useful. So normalization in vector math, in physics and computer graphics, normalizing a vector making its magnitude equal to 1 often involves dividing by the magnitude of the vector, which is this. Now, there's a question I ask myself. Why do we normalize a vector? Why do we normalize a vector? Inverse square laws. Physical phenomena like gravity and electromagnetic forces follow an inverse square law, meaning their strength is proportional to 1 over r squared. Calculating field intensity often requires 1 over square root of x. Probability and statistics. Okay, I only want to understand more one of these points. So I'm gonna take the normalization in vector math and I'm gonna ask, can you explain me why do we normalize a vector? What is the use in that? Can you give me an example of a normalization? Can you give me a real example of a normalization? Why normalize a vector? Normalization converts a vector into a unit vector, a vector with a magnitude of 1. By preserving its direction, normalization is useful because it standardizes the scale of vectors, which simplifies many computations, comparisons, and transformations. Okay, so I think I get the point in this. We have, again, my vector knowledge is pretty slim because I studied them quite a long time ago, but what I assume is the following. We can have multiple vectors and they can have multiple properties. They can have their points and they can have their magnitude. So, and you need to do some calculations. So I think that we normalize a vector because when we normalize a vector, all the computations will provide the same answers. It's gonna be easier for us to computate the computations. Yeah, computations, comparisons, and transformations. So in geometry, physics, or graphics, working with unit vectors simplifies computations like projections, rotations, and transformations. So just to, okay, let me go through this. Do we have an example here? Yeah. Ensures consistency. Normalized vectors allow algorithms to work with data of varying magnitudes without being by calculating light. Okay, now this is a real example of vector normalization. So we can calculate lightning in computer graphics. The amount of light that hits a surface is determined by the angle between the surface normal vector and the light source vector. So I have a light direction vector, the direction from the light source to the surface point, and I have the surface normal vector, a vector perpendicular to the surface at the point of interest. All right. So I normalize them. So why that? Okay, because the magnitudes can distort the calculation. Okay, this is a real life example. In physics or game development, velocity vectors often need normalization when calculating direction followed. A character in a game moves in the direction specified by vector 3, 4, but the speed is independent of the vector's magnitude, so I need to normalize it. And then multiply by a scalar. Wait. Normalizing it off, just a fancy term for division. Okay, wait. Please explain in simple terms the above paragraph, the paragraph above, and give me an example Okay, so I know what the Pythagorean theorem is. It helps us find the distance between 2 points in a 2D or 3D space. So this is the formula in 2D. If I have 2 points, A and B, so what's the distance between them? Is the x points plus the epsilon points. Just a second. Oh, sorry, I was just drawing something on my tablet and trying to understand it. Just a second. Hey, what's up? Sorry, I was answering the door. So basically, what I'm trying to understand here is the way the inverse square root functions. If you have 2 points A and B, the distance between them. So these are the points, right? So how is this working? You'll most probably construct something like this. All right. So the diagonal is, this is the x-axis, so it's our x1, sorry, x2, and this is x1, and here we have epsilon 1, and here we have epsilon 2, so it's x1, x2 plus epsilon 1, epsilon 2, and x1, x2 is x2 minus x1. So it's x2 minus x1 squared plus y2 minus y1 squared. Okay, I just wanted to make sure I understood it better. Okay, so this is how we calculate the hypotenuse. Normalizing a vector. Normalizing means converting a vector to have a length or magnitude of 1 while keeping its direction the same. And why do we normalize it? If a vector represents direction, sometimes we only care about the direction, not the magnitude. Normalizing simplifies calculations. And how do we normalize? We find its magnitude using the distance formula. All right. And divide each component of the vector by its magnitude. Imagine you want to find the direction from point AA to point 3B. So I need to find a vector. So it's at the center, and 3, 1, 2, 3, 4. No, 1, 2, 3, 1, 2, 3, 4. So let's say this is the point. So I want to find the direction from this point to this point, right? And I find the vector. A vector from A to B is the following vector. Then I find the magnitude of it, and then I normalize the vector. And the normalized vector 3/5 over 4/5 points in the same direction as V, but its length is 0. So 3/5, 4/5. Our vector from A to B is 3, 4, right? And then I want to find the magnitude of V. Ah, all right. So original vector 3, 4 moves 5 units. So a vector from A to B is 3, 4. So this is the guy in the blue. So this is 3, 4. So what is the magnitude? What is the length of V? It's 5, right? Because this is 0, 1, 2, 3. And if I do this, so it's So it's 3 squared plus 4 squared. Yeah, it's 5. So this is 5. This is the magnitude. This is the length of V. And now I normalize this. So it's 3/5 and 4/5. One. So this is 1 squared. Oh, no, wait. So 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3. So it's 3/5 and 4/5. So it's here, and this one starts here. All right. So why is this useful? Suppose you're programming a game and want a character to move in the direction of V, but you don't want the movement speed to depend on how far the target point is. No. Oh, damn. Guys, I need to go. I'm really sorry. I'll continue this some other time. I really want to understand this.